programs, particularly in a functional program, at the top level. In the programs I write in Haskell, I tend to do something like read input and then do something and then do something else. A series of phases. That's a pipeline. If you have laziness, you can make that parallel. Or if you can break the dependencies, you can make that parallel. A map, applying the same operation over a list or other collection structure, basically all the operations can go in parallel. A reducer or fold, basically a tree cascade, applying the operation between the elements of data at a time. And a farm is interesting, because what a farm is, it looks very similar to a map. If you look at my structure here, you'll think these are the same pattern. At some level of abstraction, they are. The difference is that with the farm, what I'm going to have is a fixed number of workers. Then I'm going to work out how to allocate the data items to those workers. Maybe there's one worker per core in my system. Whereas with the map, there'll be one worker per data item. So a lot more potential parallelism. And this can be a very effective way of taking something which is highly parallel today and putting it onto a system which has a relatively few number of cores. Because the number of workers, the number of agents that are actually doing the work is quite small. It can be quite small. 8, 16, 32, something of that order. Great. And of course, these can be combined. You've all heard of Google's MapReduce, presumably, just combines two of these patterns in effect. So think about the patterns. These things are functional. So higher order functions can capture parallel patterns. So for example, we can define a parallel map in Haskell, basically to be a map operation where we spark off the computation in parallel with the main body at each point. And then to build the bricks, all I have to do is to apply the parallel map over the operation which is creating the